Let us consider another important example for the degree of freedom 0. Suppose this system containing water vapors and ice, water vapor, water and ice, then all the three phases can coexist in one system at one particular point. At one particular point, ice, water and water vapors, all the three phases can coexist at one particular point, and that point has particular temperature and particular pressure. If we change temperature, then there will be disappearance of one phase out of three phases. If we change pressure, then again there may be disappearance of one of the phases of all the three phases present. If we have to study all the three phases together simultaneously, which three phases? Ice, water and water vapors. Then all the three phases coexist at particular temperature and at particular pressure. There is no chance to change the value of temperature and pressure. To change the value of temperature and pressure. Therefore, when we say that system is having ice, water and vapors, then for that system temperature as well as pressure both are fixed, and therefore no degree of freedom. Degree of freedom is 0. Degree of freedom is 0, and such type of system is known as non-variant system. Such type of system is known as non-variant system. Now let us discuss regarding to derivation of Gibbs failure. We have to derive this equation F is equal to C minus P plus 2. For that purpose, let us consider a heterogeneous system. Let us consider a heterogeneous system having number of components C, number of phases P, and we have to calculate degree of freedom F. Let us consider, once again I am telling you that the heterogeneous system consisting of C components and number of phases 2. For any system, two variables are always important. Two variables are always important. That variables are pressure and temperature. Whatever may be system, which type of system you take for the study, two variables are always there, and these two variables are pressure and temperature. Pressure and temperature. What we are going to calculate? We are going to calculate the number of unknown variables. That is degree of freedom for whom that heterogeneous system in equilibrium. Now, two variables are there, temperature and pressure. Third variable is composition. That is also known as concentration. How many phases are there? P phases are there. Now, for the purpose of simplicity, let us consider one phase at the moment. Let us consider one phase at the moment. In one phase, how many constants are there? C constants are there in one phase. C constants are there, 1, 2, 3, 4, or it may be represented as A, B, C, D, E, F, G, and so on. How many constants? C constants. We should know composition of all the constants. If we have to calculate the composition of one particular constant, then we should know the concentration or composition of all the remaining C minus 1 constants. Similar example for that idea so that you can easily understand this concept. Suppose there are 5 students in a group. Suppose there are 5 students in a group and you want to know the weight of one student. Weight of one student. Then what is important? You should know the weight of other 4 students and you will subtract the weight of other 4 students from the total weight. In this way, you will get the weight of that particular student. In the same manner, if overall concentration is known, then from this total concentration, you should know the concentration of C minus 1 constants so that you can know the concentration of remaining constant, the composition of a remaining constant. This derivation article is somewhat slightly complicated to understand. Purely mathematical concept is there. That's why try to understand with your full concentration. Already we have taken 2 variables, pressure and temperature. In one page, you should know C minus 1 concentration terms. You should know C minus 1 concentration terms, and therefore, if for one phase C